Hi, today we're going to be talking about the scientific and engineering practices that you guys are going to be doing through our hands on labs in our food science class. So, first, let's talk about what you're going to be doing and what steps you're going to be taking through these scientific and engineering practices. You're going to be asking yourself questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics, information and computer technology, and computational thinking, constructing explanations and designing solutions, engaging in argument from evidence, and obtaining, evaluating, and communicating information. So, first, let's talk about what food science is. So, food science is considered an applied science. This is the process of putting scientific knowledge to practical use. So, throughout this semester in class, we're going to be using all sorts of different terminology. First is an experiment. So, an experiment is a controlled situation that allows a scientist or researcher to determine what causes change to occur. So, what's affecting the food? So, through these experiments, we've created recipes. But when we're talking about food production and in the food industry, we talk about food formulations. It's important for an experiment or a recipe or formula to be scientific. It must be replicable. That means that you should be able to repeat the same recipe and get the same solution and same product each time you make that recipe. No matter who makes it, it should turn out the same. So, this process is continually evolving and it evolves based on new inquiries and continuing research. So, a lot of new products and new experiments become about because people inquire from food scientists. They have an idea and they want to know if that idea can become a reality. So, asking questions and defining problems is how all of these experiments start. So, you want to ask and refine questions that lead to descriptions and explanations of how the natural and designed world works and which can be empirically tested. So, that's how all research and all experiments start out. It's just somebody asking a question. But when we're asking a question, we want to make sure that it's descriptive and we can have some sort of solution or some sort of information that we get from it. So, some questions like why are you interested in this? What are the benefits of investigating the topic? How can this be analyzed? What is the purpose of your learning? So, these are going to be questions that you're going to ask yourself as you're coming up with different experiments and trying to come up with different things to research. So, through these questions, you may develop a hypothesis. So, a hypothesis is an educated guess or a prediction, or an if then statement. Hypothesis, it's okay to be wrong. I've had students in the past that after conducting an experiment, they thought it was bad that they were wrong to begin with, so then they went back and changed their hypothesis. But that's not part of an experiment. The wonderful thing about science is that some experiments can lead to more questions and a new hypothesis. So you want to take a guess based on what you know and what you have experienced. So while we're going through this, you want to develop and use models in the process. So, you want to construct models as helpful tools to representing ideas and explanations. So, this may include diagrams, drawings, physical replicas, mathematical representations, analogies, and computer simulations. So, then we're going to talk about planning and carrying out these investigations. So, plan and carry out investigations in the field or laboratory. You want to work collaboratively as well as individually. So, normally you would be working alongside a group of three other people in class, but because of restrictions, we're going to be using and we're going to be working individually, but we can still collaborate with our groups and even with other cohorts through our data and analyzing. So it's important that we're still working with each other. So investigations are systematic and they require clarifying what counts as data. So in order to do that, we need to be able to identify variables or parameters. So let's talk about what a variable is, and let's talk about some more terminology. So a variable is a factor that is being changed. A control is a standard against which you measure all changes. So in an experiment, you usually have a variable and you have a control. So here's a great representation. So an independent variable is what I change as the scientist. A dependent variable is what I'm observing. And a controlled variable is what I keep the same. Okay, so independent variable. So the variable is changed by the scientist, the I control variable. So as an example, and a hypothesis could be, if I increase the amount of caffeine I drink at night, I will decrease the amount of hours that I sleep. Okay? So the independent variable is the amount of caffeine that I am drinking. Okay. The dependent variable is the variable that might change because of what the scientist changes. It's what's being measured. So the hypothesis I just gave, the amount of sleep is going to be the dependent variable. All right. So for me particularly, maybe I lose like 3 hours of sleep. But Sally over there, she can drink caffeine and she went to sleep right away afterwards. So she didn't lose any of her sleep. So the dependent variable again is what might change because of what the scientist changes. So you want to connect variables to your hypothesis. So you want to use the independent variable to take an educated guess to what will happen to the dependent variable. And you want to write that as an if then statement. If independent variable, then dependent variable. So your hypothesis can tell you what your variables are. So if you're not really sure and you're a little confused, it can help you. So here's the example that I gave previously. If I increase the amount of caffeine I drink before bed, then I will decrease the minutes of sleep. So the independent variable is the amount of caffeine I consumed. So that is what I am affecting. That is what I am changing. And the dependent variable is the minutes of sleep. So when we're talking about our hypothesis and we're creating our hypothesis, we want to try to use increase or decrease with your variables in the hypothesis. So let's let's test our knowledge. Okay, so here's a hypothesis. If I increase daily consumption of calcium, then I will increase bone density. What do you think is the independent variable in this hypothesis? And what do you think is the dependent variable? If you said the consumption of calcium was the independent variable and your bone density was the dependent variable, then you were correct. Okay, so let's talk about some more terminology. Let's talk about variable versus variation. So we already know that a variable is the factor that is being changed. Okay, it's compared to the control. So let's talk about what a variation is. A variation is a change in the experiment. So here's an example. What fat is most palatable for cakes? Okay, so this is going to be a variation. So our variable is the type of fat being used. So our control is going to be the butter in this experiment. So you want to determine how you will measure results and control the number of variables. So our variables that you can use are shortening, lard, vegetable oil, or coconut oil. Could be other types of fat used. So other types of variations that are possible is you can use a different mixing method. You can use a different cooking time, a different cooking temperature, oops, or a different cooking temperature. So when you are coming up with different variations, it's important. So So, which kind of fat is most palatable for cakes? So here is our experiment. We have the types of fat used as our variable. Our control is going to be butter, and then our different variations will be shortening, lard, vegetable oil, coconut oil. Oops, I can't see that last one. Or olive oil. There you go. Um, so in our class, the way you might see this is that one group would be using butter, and then the other groups would be using other types of fats. But what's important to note is that we want to control the number of variables. So when we're changing something, we only want to change one concept of a recipe or a formulation. So we don't want to change fats and the temperature of the oven, as both can impact the final results. So if the outcome, we wouldn't really know what changed the effect, whether or not it was the different fat or the temperature. So we always just want to do one type of variable. So once we've completed our research and we've done our experiment, we want to analyze and be able to interpret the data. So the data has to be analyzed in order to derive any meaning from it. So we're going to have two different types of data. We can have a numerical observation. So this is more quantitative observation. So this would be more numbers. So we still need to require units. Units are very important when we're talking about science. And that's just because it can really change and it really won't make sense to people. Is it seconds? Is it Fahrenheit? Is it mass? Like, what is it? Our you can also have descriptive observations, and this is more of a qualitative observation. And we do this, and the factors are color, texture, and order. And we do this through tasting. So from that last experiment, talking about how does fat change the palatability of cakes, we would have a descriptive observation that would come from that. A question that would get more of a numerical observation would say, do the types of fat used in cake change the mass of it, increase or decrease the mass? And then you would have a numerical observation. So when we're analyzing data patterns and trends, they're not always obvious. So there are a range of tools to identify scientific or significant features and patterns in the data. And then you also want to identify sources of error in the investigations and calculate the degree of certainty in results. So when we're talking about like the palatability of fat, everybody's going to be measuring out a little bit different. And so we have to have a plus or minus degree of certainty. So after we're going to do that, we're going to use mathematics, information, computer technology, and computational thinking. So these are all tools for representing physical variables and their relationship. So they're used for a range of tasks such as constructing simulations, statistically analyzing data, applying quantitative relationships, and applying quantitative relationships. So when we're going through this, the difference between the science and engineering is that science provides explanations and engineers provide solutions. So when we're doing this, we want to read data, observations, and notes. And in that, we're going to look for patterns, common factors, changes, and questions. So for us, whenever we come up with data, we are going to have a class Excel spreadsheet where we will input our data and we will find any type of pattern in there. When we are describing and we are talking about food and we're describing the texture, odor, color, And taste, we will also be comparing to see if there's any common factors between people or between experiments. And then we want to look for answers to the questions and support for or against your hypothesis. So this may go against what you thought, and that's okay because finding out your hypothesis is wrong is just as important as finding out it was correct. If anything, I feel like that's more of a learning experiment experience. So once we have analyzed our data, then you need to engage in argument from your evidence. So argumentation is the process by which explanations and solutions are reached. So many experiments may lead you to more than one conclusion or more than one option to solve your problem. So it's important that when we're conducting experiments in this class that we're open to new ideas. After we have done that, we're going to obtain, evaluate, and we're going to communicate that information to each other. So, scientists and engineers must be able to communicate clearly and persuasively the ideas and methods they generate. So, in this class, critiquing and communicating ideas individually and in groups is a critical professional activity. So, we will be doing this through our Wednesday meets in team over Zoom, as well as through our data. So we are going to be doing this through lab reports as well, and that can assist us with this process. And then also we want to state ideas for further research. So are there more questions or do you have more ideas that can help us for more research in the future? Okay, so let's just summarize. Those were all the steps of scientific and engineering practice. Let's just kind of summarize and go over those steps. So asking questions and defining problems is how it always starts. Developing and using models, planning and carrying out investigations, which leads to analyzing and interpreting your data while using mathematics, information and computer technology, and computational thinking, constructing your explanations and designing solutions, and engaging in argument from evidence, obtaining, evaluating, and communicating information. So this is going to be your assignment for Wednesday on your asynchronous day, as you're going to be doing a variation of practicing variables.